Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Hairani, and the other two group members is Muhammad Hakimi bin Osman and Muhammad Afif Hakimi bin Muhammad Shukri. Okay, today I would like to explain the topic about AC single phase 2-pole synchronous motor. Okay, before I start the video demonstrations, we are given the task into two parts, which is part 1. I'm going to explain the video demonstration and give some result for this lab activities, and for the part 2, Afif and Hakimi are going to settle down the report, minute meeting and editing the video. Okay, first of all, I would like to introduce the equipment that we use in this laboratory. Okay, this is single and three-phase measurement, variable AC and DC supply, rectifier volt and emitter, DC volt and emitter, universal power supply, DC motor, base unit of machines, coil or rotor, and this is stator contains brush, commutator and slip ring. And then for the connections, for the red wire is the incoming, and for the black wire is outgoing. Okay, we are going to the activity number 1. First of all, we start the motor, then we switch on the drive machines, and then we bring the shaft speed to 3000 rpm in reverse mode, and then we switch on the AC single phase supply to the stator winding and adjust the voltage level to 135 volt. And then we switch on the synchronous motor rotor DC supply and adjust the current to 2.5 DC, and then the motor should pull into synchronization and run steadily at its synchronous speed. The drive machine can now be switched off. But as the shaft remain coupled, so the shaft at this remain coupled and keep run. It will now driven by it. Okay. Next, for the table 4.1, so the stator for the AC volt is 135 volt, and the current that we get is 0.6 ampere. And for the rotor, the DC volt is 5 volt that we adjust, and we got the DC current is 2.5 ampere. And then for the shaft speed is 2700 rpm. Okay, that's all for the activity number 1. Now we go to the activity number 2. As activity number 1, first we switch on the drive machines, and then with no shaft load, vary the rotor excitation current from 2 ampere to 8. Okay, and then we observe the variation of the AC supply current to the stator current. And then to get the AC current measurements, we use clamp meter for the measurement. After 8 ampere, the motor are stopped. So we can conclude by the table that we get. And then this is for the DC current that we use. We steadily use increase DC current. Okay, and then the result we get is we can now see that the AC current also increase steadily until 6 DC current. So for the 8 DC currents, we got the AC current of 0 because the motor has stopped. Okay, I think that's all from me for this activity 1 and activity 2. Thank you.